Start the So in this session we are going to deal with problems. So already we completed 2 problems. So the fault analysis problems, it is a part 1 problem. So in the part 1 you have only one problem. So I approached 2 methods. By Thevenin's method as well as your conventional circuit analysis method. So both methods I am using this problem. So this is the question we have. A synchronous generator and motor are rated for 30,000 kVA, 13.2 kVA, and both have a transient reactance of 20%. So you have only generator and the motor. So the 2 machines synchronous subtransient reactance is 20%. So the line connecting them, so the line connecting generator and motor has a reactance of 10% on the base of machine ratings. The motor is drawing, it is drawing means extracting. So 20,000 kilowatts at 0.8 power factor leading. The terminal voltage of the motor is 12.8 kV. So the terminal voltage is represented as VTM in the problem. So terminal voltage means VTM. So what is the condition and determination is, when a symmetrical 3-phase fault occurs at motor terminals, find the subtransient current in the generator, motor, and at the fault point. So only 2 machines we have. So the 2 machines is connected with a single transmission line. Their reactances are given. So the motor load determinations is also given. So our intention is we have to bring out all the currents, actual current as well as per unit current. That is the main intention of this problem. We have to find out the current, that is your faulted current, your generator current, motor current at the faulted condition. So the question is clear to you. Do you need any clarification regarding this question? Any other clarifications or details required for this problem? Okay. So directly move on to the solution. So in solution, I will start with my single line diagram. So the single line diagram is not given in the problem. We have to assume and draw it. So in the problem, they mentioned clearly we have generator and motor connected with the transmission line, just like that I'm connected. So generator subtransient reactance is 20%. Their power rating is 30 MVA and the KVA rating is KV rating is 13.2. So transmission line reactance value is 10%. Likewise, your motor subtransient reactance is 20%. The KV value is 12.8 and the power rating is 20,000 kilowatts. So 20,000 kilowatt means 20 megawatts. And the power factor is leading here. So I may represent the single line diagram into a circuit model. So the is EG double dash and the reactance is 20% J.2. Okay. So it is connected in series with your transmission line having the value of 10%. So it is generally represented in terms of J.1. So that is the transmission line reactance. So the transmission line connected in series with your motor terminal, that is motor reactance J.2 and your motor back EMF EM double dash. So it is commonly grounded. So the single line diagram is represented by your circuit model. So have you seen the dot here? So after your transmission line, at the beginning of the motor terminal, I have the dot. There is on the dot. So that dot is said to be a faulted terminal. So in the faulted terminal, we need the current. So it shows that the power system is affected by your short circuit fault. So in this condition, you have to find out your generator current, that is current flowing this terminal. Nothing but dash. And current flowing this terminal. Nothing but IM double dash. And fault is IF. IF double dash, that is subtransient fault current they are asking. So IF double dash in per unit as well as actual we need to find out. So this is about your determination from your question. So from your question, I just extracted the single line diagram. Based on the single line diagram, I developed a circuit model. So based on this circuit model, I have to perform the per unit analysis first. So the base values. Here the base value specifications is not given. In case the base values is not given in the problem, means we have to assume generator value as base values. So MVAB is 30 MVA and KVB is 13.2 kV. So I just considering my generator value as the base value. So first I need to calculate my base current. So the base current is nothing but IB, which is equal to MVAB divided by √3 times of KVB. So for generator, the MVAB is 30, √3 times of 13.2. So you have 1.312 kiloampere. So this is the base current you have in this problem. And second is actual value of the pre-fault voltage at fault point. So before the occurring of the fault, you have the voltage of 12.8 kV. It is clearly mentioned in the problem. So as you seen in the question, the motor terminal voltage is 12.8 kV. So it shows that the motor's pre-fault voltage, that is VTM. So VTM is 12.8 kV. So we need to find out the per unit value of this voltage. That is VTM equal to actual value by base value. So 12.8 base is 13.2. In per unit, your VTM is 0.9697 per unit. So 12.8 divided by 13.2. So it is a generator value, the base value. And fourth one is we need to find out the power PM. So in per unit, it is actual value by base value. Actual is 20 is given, that is 20 kilowatts. And base is 30 MVA. So 20 by 30 is 0.667. So in our basic or conventional circuit analysis, we have voltage and current power expressed in per unit. So if we are expressing in terms of mathematical, so P equal to VA cos pi. So where cos pi is nothing but power factor of the load. So next one is we need to find out what is the actual magnitude of the load current. So the load current magnitude is nothing but PM by VTM into cos pi. So the PM power extracted here is in per unit 0.667 and terminal voltage of the motor terminals is 0.9697 and power factor which is leading, the numeric value is 0.8. So if you are solving, you may get 0.8594 per unit. Clear? So now we have to consider the terminal voltage of the motor, that is VTM as reference vector, and so the load current will lead the terminal voltage of motor with an angle of cos 0.8. So I just assuming my terminal voltage as my base values, that is 0.9697 at an angle 0 per unit. So current I am having, so current is 0.8594. The power factor which is given as 0.8. So cos inverse of 0.8 is nothing but 36.86. Yeah. So the load current should be 0.8594 at an angle 36.86 per unit. So these are all the basic determinations from the question we obtained. That is, first we are getting what is your base current IB, next your terminal voltage, that is per unit terminal voltage, power, and the magnitude of load current. So we are getting your IL at last. So based on this, we have two methods. So first method, I am using my Kirchhoff's voltage law. So the unknown voltages we can easily find out with the help of Kirchhoff's voltage law. What is your Kirchhoff's voltage law? The algebraic sum of voltages around the closed path is 0. So here we have two meshes. How can I say it is two mesh? Here you have the faulted terminal. Already சொன்னேன். So this point is faulted point. So here it is faulted. So fault, it is a short circuit fault. So it is shorted. So you have one mesh, that is mesh number 1, and you have the mesh number 2. So for my mathematical convenience, I am assuming first mesh current direction should be clockwise, and second mesh current direction should be your anti-clockwise. So first I need to find out what is the EG double dash, that is the transient voltages I need to find out. So EG double dash is nothing but the algebraic sum of the drops, voltage drops, that is J.2 times of IL, J.1 times of IL plus your terminal voltage VTM. So J.2 IL plus J.1 IL is J.3 IL plus VTM. So the IL value we determined in the last step, and VTM also we need find it. That is we determined. So just substitute all the values, and in your complex mode of your calculator, you may get the value of EG double dash as 0.8406 at an angle 14.2 per unit. So this is the mesh 1 voltage we obtained. Likewise, we need to find out what is the mesh 2 voltage. So here it is anti-clockwise. So EM double dash plus J.2 IL equal to VTM. So VTM we know 0.967 minus of J.2. J means 90 degree. 0.2 at an angle 90 into IL is 8594 at an angle 36.98. If you are solving, the result should be 1.0789 at an angle minus 7.32 per unit. So this is the voltage obtained from your mesh number 2. And our intention is we have to find out what is the fault current, IF double dash. So at faulted condition, IF double dash is IG double dash plus IM double dash. So still we need not find out the generator current as well as motor current. So by your Ohm's law, that is IG double dash is EG double dash by J.3. So it is known to us that is 0.8406 at an angle 14.2 divided by 0.3 at an angle 90. So the arrow indicating here is the answer. Answer for first IG double dash is 2.802 at an angle minus 75.8 per unit. So that is generator's subtransient fault current. So next one is a motor subtransient fault current IM double dash is EM double dash J.2. So 1.0817 at an angle minus 7.3 divided by 0.2 at an angle minus plus 90. So the answer is 5.4085. So what is our intention? The fault current. So IF double dash is IG double dash plus IM double dash. So 5.4085 plus 2.802. So you may get 8.081 at an angle minus 90 per unit. This is the final solution you have from the KVL method or basic circuit analysis method. The same thing or the same solution we can obtain with the help of Thevenin's theorem. So this is the last step. So result, once you find out, you have to write the result separately. So in the problem, they asked subtransient generator current, subtransient motor current, and subtransient fault current. I am multiplying with 1.3116. Why I am multiplying here? In case of actual value, you need to multiply with your base current. So first step, we obtained the base current value. From the first step itself, we obtained the base current. That is IB 1.312. So I am taking 1312 value. So just multiplying with all the values and getting my actual values. That is 3.67 at an angle minus 75.8 kiloamps and 7.06 minus 97.3 kiloamps. And last, the fault current IF double dash is 10.603 at an angle minus 90 kiloamperes. So this is the solution we obtained it from your KVL method. So method 2 is we can use my Thevenin's theorem. So what is the Thevenin's equivalent voltage? The open circuit voltage in series with your Thevenin's equivalent impedance in series with your load. So fortunately, we doesn't have a load here. The terminal is shorted. Okay. So the voltage source should be short circuited. Current sources should be open circuited. We don't have any current sources. So the voltage sources EG double dash and EM double dash gets short circuited, and the open circuit voltage VTH we may assume as your terminal voltage, that is 0.9697 angle 0, that is your pre-fault voltage value we are just assuming, and J value, that is J.2, J.1 in parallel with the J.2. So while solving this, you may get a J 0.12. So just have this solution. That is, this is the Thevenin's equivalent, VTH and ZTH, and we need to find out IF double dash, short circuit. The solution is quite simple. So your VTM is 0.9697. So from this we can get I1, I2. So I1 current we are getting and I2 current we are getting. So IG double dash is I1 plus IL. That is 3.2323 and IL we know. So ரெண்டுத்தையும் add பண்ணிட்டீங்கன்னா உங்களுக்கு 2.802 கிடைக்கும். Likewise IM is I2 minus IL. At last you may write the results. So it is an important university question. You may get the question in your examinations. So you can write any method. Either you proceed with your Thevenin's method or with your KVL method. But that 5 steps is compulsory. The 1 to 5 port only. So 1 base current, actual value, terminal voltage, power, அதுக்கப்புறம் current. இது வந்து காமன். ஸோ இதுக்கப்புறம் வந்து பார்த்தீங்கன்னா கொஸ்டின்ல வந்து தெவினியன்ஸ் ஸ்பெசிஃபை பண்ணிட்டான்னா you approach with Thevenin's. Suppose not specified means you can use any method, either KVL or Thevenin's. It is up to you. Do you have any clarifications required for this problem or doubt? If you have a doubt means you may ask now. just clarify the doubts in this session itself. Do you have any doubts? Shall I continue further? Do you have any doubts, students? யாருக்காச்சும் டவுட் இருக்காமா? இப்பதான் ஒருத்தன் ஜாயின் பண்றான். இவ்வளவு நேரம் என்னடா பண்ணிட்டு இருந்த? Okay, shall I continue further? மறுபடியும் கண்டினியூ பண்ண அடுத்த ப்ராப்ளம் போலாமாப்பா? யாருக்கு ஏதாவது டவுட் கேட்கணுமா? கேட்கணும்னு இருந்தா கேளு. In your chat box, I will attach the PPT. Fault analysis part 1. In chat box itself, you may get your PPT. Recorded when I am arriving to the college, I will upload the video. Okay. So one theory question I will touch up in this session. So next class we discuss the fourth problem. So I said that the one theory question is very important in this unit. I just cover up the theory question now. So one is the symmetrical analysis flowchart. The flowchart is most important. You may get 10 mark, 8 mark or 6 mark. So with the procedure. So I just explained the flowchart. You may, based on the explanation, you may write your algorithm by your own. So first is starting process. ஒரு நிமிஷம் பா ஷேர் பண்ணிடுறேன். I hope now my screen is visible to everyone. So symmetrical analysis flowchart. So using ZBus method. So நம்ம ZBus வச்சு நம்ம ப்ராப்ளம் போன கிளாஸ் சால்வ் பண்ணோம் இல்லையா, அது எப்படி வருது அப்படின்றதுக்கான ப்ராசஸ். So first is starting process. So once the start initialization is over, we have to read the declarations. So we have to declare your line data, bus data, the faulted bus, subtransient reactance of each machine. So once the reading is done, we have some assumptions. We have to assume the pre-fault load currents. We are just assuming 1 at an angle 0. Shunt elements in the transformer tabs, shunt capacitance, series resistance of the lines are neglected. So next we have to draw the pre-fault per phase network. So it is a positive sequence network. In the next unit I will show what is positive sequence network and what is negative sequence network and what is zero sequence network. So now just to hold this term. So fourth unit full and full we are dealing with your sequence networks. So அடுத்த யூனிட் வரும்போது அது நான் என்ன அப்படிங்கறத சொல்றேன். So obtain ZBus matrix using ZBus building algorithm. And next one is obtain the
screen visible ஆ சார்.
ஸ்கிரீன் தெரியலையாமா?
ஆமா சார்.
தெரியலையா? கிளியரா தெரியலையா?
தெரியல சார்.
சுத்தமாவே தெரியலையா?
சார்.
ஒரு நிமிஷம் நான் செக் பண்றேன். இவருக்கு மட்டும் தெரியலையா? எல்லாருக்குமே தெரியலையாமா?
Participants தான் காட்டுது.
Now it is visible ma? Now I shared the content only. Now it is visible?
No sir.
கிளாஸ் தானே போய் நடுவில் ஏன் கூப்பிடுற? சரிம்மா, அந்த பிபிடி தெரிஞ்சுதாம்மா விசிபிளா? பிபிடி தெரிஞ்சுங்களா? இப்போ தெரியுதாப்பா? ஸ்கிரீன் தெரியுது இல்லையா? ஃப்ளோ சார்ட் தெரியுது இல்லையா?
இல்ல சார்.
Okay. Wait a minute. Now it is clear. இப்போ தெரியுதா ஸ்கிரீன்? இந்த பெயிண்ட் ஸ்கிரீன் தெரியுதா?
நோ சார்.
சரி, ஒரு நிமிஷம் பிபிடி ஒன்று இருக்கு, அது ஷேர் பண்றேன். தெரியுதாப்பா? இப்ப தெரியுதாம்மா?
இல்ல சார்.
தெரியுதா?
நோ சார்.
என்னடா இது? இதுமா இந்த ஸ்லைடு தெரியுதாமா? ப்ளூ கலர்ல ஒரு ஸ்லைடு தெரியுதா?
நோ சார், இன்னும் ஒண்ணு தெரியல சார்.
சரிடா. என்ன ப்ராப்ளம் தெரியல. எவ்வளவு நேரம் தெரிஞ்சது, இப்ப ஏன் தெரியலன்னு தெரியலையே.
சார் ப்ராப்ளம் ஃபுல்லா தெரிஞ்சு சார். அதுக்கப்புறம் தியரி எடுத்து ஆரம்பிச்சா போயிடல சார்.
ஓகே. டைம் இருக்கு, எனக்கு நிறைய டைம் இருக்கு. சரி, நான் செஷன் ரெஃப்ரெஷ் பண்ணிட்டு மறுபடியும் லாகின் பண்றேன்ப்பா. எல்லாரும் அப்படியே லைன்லயே இருங்க. பி ஆன்லைன்.